Hello guys, we finally come to the last topic of IG syllabus, which is this cumulative frequency and box and whisker plots. So let's get started. Okay, let's do cumulative frequency first. Okay, cumulative frequency is done by adding the frequency as we go along. So you don't have to worry this thing. Later I'll show you some example. Okay, it is useful when we try to calculate the median in a large set of group data. Let's say we have a lot of data. We don't do like canceling the right and left and then until you get to the middle one. We can use this cumulative frequency to do it. Okay. So actually, we also can use this to try to establish how consistent the result is in the set of data. Okay, so let's see one example here. So actually, this study is about two brands of battery, which is a battery A and battery B, and then they are tested, and then 50 of them are tested, and then see how long can that battery last. So we have a figure here. So let's say between 0 to 5 hours, this battery, 3 of them can last until 5 only, and this one is you have 5 last until 10, and so on. These are the frequency. So the cumulative frequency, you can see that actually I add one more column here. So the way is you start with the first one, which is 3, this one. Then after that, we keep adding from this one, cumulative frequency. We try to add the second one, which is the 5 here. Then we get the result. That result, we write it here. So it become 8. So we do the same process until we reach the end here. So you keep adding this plus equal to this, adding this equal to this, adding this equal to that. So the last one should give you the total frequency, which is when you add all this together, which is 50. If you get some numbers that are different from here, that means something wrong with the in the process. You can see for type B, I'll do the same thing. So I'll fill in all this, start with 1, 1 plus 1, you get 2, 2 plus 10, you get 12, and so on. So this is how we get the cumulative frequency from the table. Okay. So after that, when we have this table already, we can convert it into a diagram, which is a frequency diagram, a cumulative frequency diagram, or we can call it as ogive. So you can see I'm using type A to show you an example. In fact, you need to compare two, which is type B also, but type B, I don't have space to put this table here. So I just show you here, you look, the type B is at the previous slide. So this is a cumulative frequency. So you can see from here, I draw a XY grid here, something like this. So this part is cumulative frequency. This part is cumulative frequency, and this part will be the range, the duration, whatever. It can be high, it can be anything. Okay, so looks at how do we plot the graph. So actually, we are using upper boundary for each class to plot this graph. So you can see from here, I start with 5, the upper boundary, and then I mark here 5 here, and then this is the frequency from these 3. So with the second class will be 10. So I start with 10 here, then reach 8 here. So this one will be 8 here. So I continue 15 with 16 here, 16, and this one will be 20 with 26, and so on until I reach 50. So we can see the last one will be 35, and then the last one should be 50 right here. So after that, we connect all the dots together to make a smooth line here. And you can see there is a tail here. Normally we end it, we connect it with 0 because just imagine we start with 0. So you just connect one more class here, make it into start with 0. Okay. So this is how we plot the ogive, this graph. Okay. So the median, how do we find median from this graph? Okay, you can see our total frequency is 50. So the median is actually at 25. So you read the value of 25 right here. Then you draw a dotted line until you touch this graph just now. Then you see the figure here. So in this case, for type A, for battery A will be about 19, sorry. So for type B will be 18, about 18. Of course, this graph, if you draw it nicely, you can read the figure easily. This is just roughly. Okay. Then let's see another few things that we can read from the graph. Imagine you have another cumulative frequency graph like this. Okay, so now you can see this one is 120. That means the total frequency is 120. Okay, the cumulative frequency axis can be represented in terms of percentile. It can be represented in terms of percentile. That means this is 120 is considered as 100%, right? So the maximum value of the frequency is 100%. Just imagine this is 100% right now. So median is actually at the 50 percentile, which is the 50% of the total frequency like this. Because our total frequency is 120, so 60 will be the median. So you read from here, and then this Q2 is actually the median, the value of the median. So in lower quartile is actually 25 percentile, which is 25% of the total frequency. In this case is 30. So you read from here, and then you touch this line, and then see Q1 will be your answer. Remember, Q1 is your answer, not 30. We have to read this, the value here. Okay, the upper quartile will be 75 percentile, which is 75% of the total frequency. In this case is 90. So you can read from here, Q3 is our answer. So if let's say the question is asking for 80 percentile, then you use 80% times 120, and then you see the figure, which is something here, then you touch here, and then you see what is the value there. Okay, it's not necessarily must be median, lower quartile, and upper quartile. It can be any, it can be like 10%. 10%, then there will be 12. That means you read the value from 12 here, and then touch here, and then you see what is the value there. All right. So interquartile range is actually the upper quartile minus the lower quartile. So the value of Q3 to minus Q1. So it's actually a measure of spread. So the range. How spread is the data? Is a one type of the measurement. How do we do a spread? Okay. So next one. Okay, now let's say we have two graphs here, type A and type B. We need to do some comparison. So the median is at 50, right? 50%, which is 50% in this case is 25. You can see our total is 50, so 25 is actually the median. Okay, all right. By using the graph, we can see lower cutoff for type A. Type A is 13 hours, right? The lower quartile is here. 12, you can see 12, we read from here, and then this is about 13 here. Okay, so the upper quartile will be from here, 37, and then the answer is 25. And the lower quartile for type B will be 15 about, and then for upper quartile is about 21. This is upper, lower, upper, and lower for type A and B. This is how we read the graph. The interquartile range will be 25 minus 13. 25 minus 13, you get 12. And then for type B will be 21 minus 15, you get 6. So you can see from here, this value is much lower than the type A, which means most of the battery lasts about the same with the median. As if this interquartile range is smaller, that means all the value is actually very close to the median. I mean, it's very consistent. That is what we call it. So the conclusion is type A is on average long-lasting battery only, because you have a big spread here, a bigger spread here. That means median is right here. Median is right here. So some of the battery is much longer, and then some very short. So the range is very big. Whereas for type B, it is more reliable because everything close to median. The range here is very small. Okay. Okay. This is about cumulative frequency. And next, we try to learn what is called box and whisker plot. The information from cumulative frequency graph can be represented in the diagram called this box and whisker plot. This is like something I don't like, piston, I don't know. So this part is actually the minimum value. This is the maximum value, which is 0. That's if we compare to the batteries, that's how the 0 will be here, the 35 will be here, because the longest hour that the battery lasts is 35. Okay, this rectangle here, so this is the value where the lower quartile is, and this is the median, and this is the upper quartile. Let's see the example to compare the battery type A and B that we discussed previously. So you can see the duration of the battery is from 0 to 35, both of them, because we are testing at the same method. Okay, so you can see both battery types have the same overall range, 0 to 35. And from these two graphs also, you can see the median here. These two are the median. The median for type A is higher than the type B. Okay, the type A median is bigger than the type B, which means it slightly lasts longer than type B. Okay, but the spread of the median, the spread is actually the upper quartile minus the lower quartile, right? So you can see from here, it's actually represented by the rectangular block here, this block here. So interquartile range is this one minus this one, and this one minus this one. You can see for type A is quite big, and for type B is so small, it's smaller than type A. So this one implies that the median is more consistent for type B. So because the interquartile range is shorter, maybe smaller than type A. Okay, so this is all about box and whisker plot, right? So I think that is the end of this chapter, and I will attach one worksheet for you to do. Okay, thank you and goodbye.